Once we remove material remains from in situ, right? Once we've dug things out of the ground, we've got to figure out how old those things are. And some of that comes from systematically kind of like mapping kind of the vertical space that things are in, vertical space in terms of like the strata of sediment deposits. And some of that comes from um, actual um, radioisometric dating techniques, actual physics and chemistry techniques that enable us to get a range of ages. So, when it comes to dating the past, that's necessary both for biological anthropology and for archaeology. We sometimes um, employ methods known as taphonomy. These are the study of processes that affect the remains of dead animals. There are, for example, some body farms. Knoxville, Tennessee has one of the country's largest body farms where people who've donated their bodies to science, right? Sometimes that science is burying them and digging them up at various stages of decay to determine kind of how like natural decomposition happens. So taphonomy is one vein of that. Paleoanthropology, um, of course, looks at ancient humans and their immediate ancestors, right? Paleoanthropology also looks at the remains, though, of like prey items, for example, like um, other materials that they use within a site. So, over kind of the history of the development of both paleontology and paleoanthropology, we've been able to determine a established time frame or chronology for the evolution of life on Earth. And so the first technique here that is the relative dating techniques. I'm going to ask you to be able to identify between the two techniques of dating remains. And uh, from that um, from that kind of definition, I want you to identify the similarities and differences between relative dating and absolute dating. Okay, we are also going to mention briefly different radioisometric techniques like carbon 14 dating, etc. But I'm not going to ask you on like a test context to be able to distinguish between like carbon 14 dating and potassium argon dating, for example. Okay, so I want you to know, kind of in this general sense, what's the difference between absolute dating and relative dating. Okay, relative dating makes use of stratigraphy, makes use of this time frame in relation to other strata or layers, while absolute dating gives you a date in numbers with an established or predetermined kind of range of error. Okay, so stratigraphy is the study of Earth sediments that are deposited in demarcated layers. There are a couple good places in New Mexico for appreciating stratigraphy, so to speak, right? One of those is a drive from Bernalillo to Cuba. If you drive out that way, right, you through like the Jemez and stuff, you can really see just on the sides of the roads as you drive, you can see how there are these clearly demarcated layers of sediment of different colors and kind of different orientation. Another area is the Abiquiu area where you can really see these different layers of dirt. So that gives you an idea of what we mean by stratigraphy. Um, Fossils and artifacts in a given stratum are younger than those in the layers below them and older than those in the layers above them. So, this idea of the law of superposition, right? Older things are deeper down. Newer things are closer to the surface. So we can look kind of at where the um, the material remains that we find, where they're buried, what they're above, what they're below, to determine kind of a relative time frame that it's in this, let's say, this Pliocene kind of age range, right? And there are some consistencies. A lot of the work that's done, or a lot of the excavation that's done in New Mexico, we place fossils, for example, in the Rocky Mountains. We've got some pretty clear cut presence or absence of particular species that help us to figure out how old a given stratum is. And so there's some consistencies from Wyoming all the way down to New Mexico, that there are certain indicator species that only occur in certain layers. And so if we find that indicator species, we know basically how old that particular layer is, and then we can use that to further date things that we find above or below it, right? And so, these pictures demonstrate that idea of stratigraphy, right, where we're able to note that at certain depths we've got sediment layers that are roughly, I think here in this middle photo, 10,250 years before present, right? And so this picture shows you that kind of painstaking labeling that has to be done as you're excavating your grid area. Okay, so you see that each of these pins is placed in where something has been found. And so by measuring that depth and then dating the sediment that's around those objects, you're able to get a rough idea of how old those objects are. And so this is particularly being done in the Blombos Cave area of South Africa, which, if you recall back to our discussion um, with hominin evolution, right? The Blombos Cave had some of those um, older or anatomically modern Homo sapien fossils, for example. The Blombos Cave also um, has material remains that indicate that people were making jewelry, for example, and ceremonial knives and things like that. Absolute dating techniques give us more precise date ranges of artifacts and fossils. We get dates in numbers, with, of course, some kind of determined margin of error. And many of these absolute dating techniques are based on radioisometric techniques, known rates of radioactive decay of elements. And so the one that probably all of you have heard of is carbon 14 dating, right? Carbon 14 dating is only useful for organic material up to about 50,000 years ago. So there have been organizations like Answers in Genesis who have carbon 14 dated dinosaur fossils, which is interesting because dinosaur fossils are no longer considered organic material, right? Everything in them has been converted to stone, and they certainly don't fall in this window of more recent than 50,000 years old. Okay, so we can apply inappropriate dating techniques and we get numbers that are basically bunk, right? We get numbers that don't really give us any information. They date things like contamination, they date the skin cells from the people who've handled those materials, etc. All right, so we've got the potassium argon series that dates minerals and rocks to more than 500,000 years old. The uranium series, specifically looking at U-238, can date the ages of ancient lake beds, coral, mollusks, reliably up to 500,000 years old, but potentially even millions of years old. There's thermoluminescence. This is used a lot in dating pottery. It's really reliable up to about 100,000 years ago, which, I mean, we weren't really, we don't have pottery remains from really old ages anyway. And we don't, we can't firmly say that humans more recently than anatomically modern Homo sapiens were using pottery, right? But anyway, thermoluminescence is very reliable up to about 100,000 years ago, potentially can date up to about 300,000 years ago. And then we've got things like electron spin resonance that can date calcium carbonates. This can include teeth, bones, eggshells, mollusks, potentially older than 300,000 years. So I really like this next graphic that just gives you kind of the ranges over which certain techniques are useful, right? So writing only dates back to about 5,000, 6,000 years ago. So that's, you're only going to use writing with what we call historical populations, not prehistorical populations. Writing is used as that hallmark that denotes the difference between history and prehistory. So prehistoric predates writing. Um, we've got polar wandering. We can look at the orientation of iron deposits in sediment to determine exactly where was polar north at that moment that those iron deposits were laid down. Dendrochronology, counting tree rings, right? That can be useful for the trees that were used in building structures and such, but that relies on kind of knowing the patterns of how those rings in the trees are laid down. We've got radiocarbon to 50,000, amino acid racemization to about 100,000, thermoluminescence to 100,000, electron spin resonance to 100,000, fission track, which is looking at um, specifically the fission patterns of some of these radioactive substances that can date to millions of years old. Potassium argon can be to millions of years old. And um, then we've got this other feature that's kind of amusing to talk about just because it's something that's been on the radar um, for scientists really a lot over the past like 50 years or so, and that is paleomagnetic or polar reversals. We are overdue for a paleomagnetic reversal. Okay, what happens with a polar reversal is North Pole becomes South Pole becomes North Pole. The Earth doesn't flip, but we can look at the orientation um, of iron in sediment to determine whether or not a polar reversal has come. And so these generally have happened every, I don't know, like 500,000 to million years, and we're overdue for one. So that this is something that's been kind of chatted about in pop science headlines over the past year in particular. All right, so depending on whether you find um, things that would be classified as skeletal remains versus things that would be classified as fossils, that's going to determine the techniques that you use to date those remains. Um, in both bioarchaeology and paleoanthropology, it is useful to have a good understanding of bone biology. That is the processes or study of bone as a biological tissue, and how things like disease and injury can leave marks on the bones. And so paleopathology specifically looks at that role of disease or injury in skeletons from sites. So this is really important with respect to bioarchaeology. One crossover that's often pretty popular between archaeology, paleoanthropology or biological anthropology, and criminal justice is, of course, this crossover with forensic anthropology. And so forensic anthropologists work within a legal context to recover, analyze, and identify human remains. There are things that you can predictably tell from human remains, depending on um, like how much material you have present. You may be able to accurately date the age of the remains, meaning that you were able to say how old the person was who died, right? You may be able to determine the sex of the individual who died. There are some predictable differences, particularly with areas of the body like the pelvis, that can be useful for sexing some skeletal remains. You may be able to determine to a less reliable degree the ethnicity of the individual. There are some predictable differences between teeth that come from African continent versus particularly Asian, like East Asian, Central Asian, and then Western Europe. But there's a margin of error with any of these things that are kind of based on broad categories of people. Paleoanthropologists in in Albuquerque have been used in these forensic kind of contexts. There are some who routinely collaborate with the Office of the Medical Investigator. Osborne Pearson from UNM was involved in trying to figure out how many individuals were present in the bodies that were recovered on Albuquerque's West Mesa and the approximate age and and uh, ethnicity of those particular remains. So, forensic anthropology is absolutely kind of this applied dimension of both biological anthropology and archaeological anthropology. There are other measurement techniques such as anthropometry. This is where you measure human body parts and dimensions. It can include things like body mass composition, that's used with extant populations to determine nutritional status, but it is also um, dimensions and such are used widely with this bioarchaeology context as well. And so, yet another area where there's a lot of crossover. All right, so the predominant techniques, of course, are systematic survey and excavation. Definitely make sure that you've paid some attention to this paradox of archaeology, the fact that we destroy sites as we excavate them. Uh, that destruction of sites as we excavate them is certainly one of the ethical issues that is present in any study of historical or prehistorical populations. But we do have to talk about some other ethical concerns. And so science exists in society and in the context of law and ethics. One kind of example of this is that, if you're going to study, whether you're studying animals or people in a foreign country, right, you have to abide by the legal um, policies, by the laws of whatever country that you're working in. I have a friend who ended up being imprisoned in Namibia, for example, because she brought Benadryl in with her because she had some allergy issues, and it turned out that Benadryl was a controlled substance in Namibia. So you've got to know those kind of uh, ways in which you know the differences in legal codes between different sites. In the value or the context of international contexts, there are going to be different ethical codes and value systems. And we've got to recognize that a lot of the work that anthropologists do, whether archaeologists or biological anthropologists, that this is in the context of members of international teams. Right. To even do anthropology well, let's say, the American Association of Anthropologists has come forth with a statement that basically says you've got to involve local people in your research. And so you've got to make contact with professionals in the area in which you're doing your work. If there are indigenous populations that still inhabit the area where you're doing your work, you've got to consult with them and make sure that you're respecting their cultural traditions while you go through this process of survey and excavation, right? One thing that a lot of human populations don't really appreciate, for example, is having dead bodies dug up, right? So, kind of respecting the sacred nature of burial sites. So we'll start with that American Anthropological Association Code of Ethics, and then kind of go on from there. So the primary ethical obligation that anthropologists have is to the people, the species, and the materials that are being studied, even before their obligation to their funding agencies or their institutional affiliation. Right? They've got to respect the people, the sites, the materials that they're working with. One big thing from the AAA Statement of Ethics surrounds this issue of informed consent. Okay. Anybody, like the people that are being studied, people who have claim to the sites that are being studied, etc., they have to consciously agree to take part in the research after being fully informed about its purpose, its nature, its procedures, and its potential impact. So, there's been one kind of ethical shift that has happened over the past 15, 20 years where, the history of archaeology was basically the history of grave robbers. Right. That really, when you came down to it, the way that collections were obtained for museums and private collectors, right, was through grave robbing. And so when we think about movies that sensationalize that, like the Indiana Jones movies, right? I mean, that's basically what Indiana Jones is doing is robbing graves that are sacred to local populations. And so a lot of the material that have been in museum collections have been found to be fraudulently or uh, obtained or just flat out stolen. And so um, that obligation then that line of who who are your primary ethical obligations for, right? Become a little less clear cut, and there have been some situations where even our local museum of anthropology over at UNM, the Maxwell Museum of Anthropology, that they've had to gift artifacts that have been in their collection for um, decades back to the people from which they came. And so there was an example of this. I think it's been about 10 years. There were three Namibian kings who came to tour Albuquerque. This was part of like designation of Albuquerque as like a sister city to some of these populations, etc. And they toured the Maxwell Museum and they found an artifact that came from one of their tribes. And so the curator of the Maxwell Museum, in a very public kind of press conference sort of context, made a gift of these artifacts back to these Namibian kings. Um, Another situation, the one of the hallmarks or kind of prize pieces of the Maxwell Museum was a totem pole that had been um, taken from or gifted from a big contributor to the Maxwell Museum and to the collections. And that totem pole had been kept out in the courtyard. Well, about 5 years ago, maybe a little bit longer, the university worked with the family of the people from whom this totem pole came from and kind of made a pledge. I mean, the family didn't want it back. They were like, you guys can keep the totem pole, but they wanted it to be restored and they wanted it to be displayed inside in a climate controlled kind of environment so that it wouldn't deteriorate. Because for them, the spirits of these totems, um, the spirits inhabit these totemic representations. And so to leave it outside in the sun, the rain, etc., was disrespectful to their religious beliefs. So, that particularly when we're talking about museum collections, there are reparations that have to be made. Right. All right. So informed consent is really, really important. Anthropologists must work to avoid the exploitation or harm of individuals, of the groups they study, of animals that are part of those groups that they study, or of cultural or biological materials. And so, specifically for North American anthropologists, and we're talking about this because we are in the U.S., right? Those working in other countries should always include host country colleagues in their research planning and requests for funding. They should establish truly collaborative relationships before, during, and after field work. They should include host country colleagues in the dissemination of research results. That is, their name should be on as authors of that publication. And they should ensure that something is given back to host country colleagues. And of course, depending on what subfield of anthropology we're talking about, that giving something back can look very, very different, right? So, in the context of plundered grave goods, for example, right? Giving something back can involve physically giving something back, giving these artifacts back to the people from which they came from. In the context of working with indigenous populations, kind of bridging that gap with cultural anthropology, I can think of a really good example. I have a friend, Matthew Schwartz, who uh, worked with the Tsimane, who are um, hunter-gatherer horticulturalists in Bolivia. And while he was there doing his research, and he had a grant, and it was, finite kind of funding opportunity during which this work had to be done, a finite amount of money. He There was a record flooding that was like unparalleled um, in recent history. And so what this ended up doing was flooding the river along which all of the Chimane villages are and displacing um, thousands of people. And so Matthew had to totally suspend his research and his way of giving back was to start a money and food drive, basically, to get these people things back because they had just planted for the springtime planting, so they were losing crops. They lost their houses. They lost clothing. I mean, many of them escaped with literally only what they had on their backs, so they didn't even have like plates and utensils and things to cook in or eat off of. No way of getting clean water because with the flood, their water sources had been flooded and contaminated, and so he really had to put all of his data collection on hold just to kind of fulfill this obligation that he had to the Chamane themselves. If you're working with primates in biological anthropology, right, that may then include something to do with conservation, or that may be something to do with the local communities that rely on the same area where those primates live, right? So you may give local populations some agency in terms of supporting ecotourism, having economic opportunities that aren't at odds with conservation goals, etc. There are also these ownership issues. We've had disputes over the ownership of human remains, artifacts, and heritage items. Lawsuits against museums are becoming more and more common. And in North America specifically, we have, the United States specifically, we've got NAGPRA, which is the Native American Grave Protection and Repatriation Act. This is why I say that if you find human remains, don't ever remove them. Don't move them at all. Take a photo of it, document the location, and reach out to local authorities. I mean, obviously, if it's like a recently deceased body, call the police, right? But if these are pretty old human remains, you can reach out to most major universities have an office of contract archaeology. That's a good place to reach out. The state office also has like a state archaeologist on record. So these are the kinds of agencies that you should inform. And so this code of ethics helps to guide decisions involving ethics and values, right? We recognize obligations to the scholarly field, to society and culture, to the human species, other species in the environment. But when it comes down to it, right, that first and primary obligation has to be to the individuals themselves that you're studying or the most recent living relatives of those individuals. So, in summary, know the ethical obligations of anthropologists through this AAA statement of ethics. Understand how both biological anthropology and archaeology are multidisciplinary. Distinguish some of these primary areas of study. Be familiar with systematic survey and excavation as the primary field methods of archaeology, as well as how that creates this paradox of archaeology, and understand why the fossil record's not necessarily a representative sample of all the plants and animals that have ever existed, and how we might make use of fossils to help us both establish relative dating schemes as well as absolute dates.